recent years is multidisciplinary in research groups and diverse applications of scientific products. This feature has helped maximise the strength of each member, creating a total power, comprehensive view in researching and improving products. We are proud that the percentage of students who have the right major in their studies is always over 80% and become active contributors to development of their workplace, region and country. Believe in yourself, create good values for life, learning by design.
Pleasant.
Legend has it that there was a huge tree of Dictorocarpus alata family, towering over the mountains and jungles protecting all creatures. Since then, the land blessed with the tree was called Toyomo. To means hat. Yao refers to that tall, straight, evergreen tree found in the Southeast Asia, and Mo means number one or pioneering. The geographical name was used hundreds of years ago, and it became symbolic of our forefathers' wish for a favorable land area that meets the three requirements: appropriate terms, suitable place, and potential people for the rapid development. With strong historical and cultural significance, the public university of Binyang province had the honor to be named Toyomo University in the spirit of continuing and developing the great values that the forefather had built up, with desire to rise at a dictatorial countryside, become the leading uni in the country and the region. History of university development. Back in time, the predecessor of Toyomo University 2009 today is Hieu College of Pedagogy 1997, which was known as School of Pedagogy in Songba Province from 1976. More than 30 years of implementing teachers training from preschool to high school, the pedagogical school has completed the mission to provide great human resources for the education sector of the province. In order to welcome many great opportunities of the country and ready for the important changes of Binyang province during the fast and strong economic development time, there is the need for the qualified higher education institution to meet the people's learning demands on the spot. In May 2001, the projects of establishing a public university in Benue province were officially issued. In June 2009, the Prime Minister issued decision number 900 QD-TTGs formally establishing Toyomo University, setting the first radiant step for the journey of conquering knowledge over the past 10 years of the university. Achievement in 10 years. In terms of streaming, in 2009, even though many universities in Vietnam were still applying the traditional education system, Toyomo University, as a new established university, was destined to completely transform the credit system in all majors, helping students proactively design routes. In 2013, Toyomo University approached the CDLO initiative in improving training programs, aiming to build high-quality human resources to meet the actual needs of enterprises. In June 2015, Toyomo University was honored to become the third university in Vietnam to join CDLO work organizations. From here, TDMU boldly builds its own direction with positive integrated education method, taking learning as a center. From 3,500 students in 2010 up to now, it has increased to 15,000 undergraduate students and 1,000 postgraduate students who study and research in 26 undergraduate, 9 graduate, and 1 doctoral programs. The proportion of students who got jobs after graduation is always over 90%. In terms of science and technology, in 2018, for the first time, Hieu University's name appeared at the 42nd position within the top 400 universities and research institutes in Vietnam for the amount of scopus articles. From the early days of establishment, Hieu University always considered scientific research as an important key to help the school move forward fast and steadily in the progress of our journey to become a navigator of knowledge. TDMU has issued many policies to encourage lecturers to participate in scientific research, such as rewarding for publish in Scopus, international journals, and ISI, forming interdisciplinary research groups to implement four important scientific projects that the university is pursuing: Southeastern Study, Smart City Research, Urban Agricultural Research, and research on the quality of education. Besides invest in research projects, scientific conferences are also organized from unit level to international level, starting from the humble position of a school that learn experiences and coordinate with other organizations. Up to now, Hieu University has become the focal point to actively innovative the research direction and association of domestic and foreign universities participate in prestigious workshops. In terms of international cooperation, in August 2013, the university signed an MOU with National Bingtung University from Taiwan to begin the process of establishing international relations. Until now, Hieu University has become a partner in training and scientific research with 31 educational institutions in the world. Every year, we carry out many activities of exchanging teachers and students, receiving interns to organize for volunteer activities and cultural exchange. From here, many foreign experts keep coming back to work and collaborate long-term with the school because of the friendly environment and hard-working lecturers. In terms of quality assurance, in November 2017, the university was recognized to meet the national standards of education quality accreditations. In December 2017, Hieu University became an associate member of AUN Network, Asian University Network. In terms of serving the community, as a university, the mission do not only stop at strengthening human resources to meet the social needs, but also guiding for knowledge, supporting the community for a progressive society. Every member of Hieu University is working hard to contribute to the modern development, form a culture of responsibility to the community. In terms of university administration, the achievements in the past 10 years are built on a solid framework of modern and effective university management strategies. The university has put all of its strength in building a professional team of lecturers according to three criteria. Applying the World University Management Model from March 2018, the school board was officially operated, including 14 members who are veteran managers, scientists, lecturers, and business who plays an important role by measuring and helping the university to constantly review and evaluate for improving the quality of operations. From here, the university administration system was completed, becoming a solid support for the strong development of the university later. The future of Hieu University. Over 10 years of establishment and development, TDU has escaped the old path to create the vitality and aspirations of the new university, a multidisciplinary university with new orientation and international integrations. Due to the interest of Binh province leaders and agencies The strategy of promoting the capacity of the lecturers and bringing together national as well as international educational scientists to create strong resources for the development. Mission become a multidisciplinary university according to advanced and modern international standards. Vision become one of the top 350 best university in Asia. Students have the ability to work abroad. In the journey of achieving that desire, with the sharing and the convenience of domestic and foreign educations and technology experts, the smart university model has gradually gotten in shape in comparison with the current potential of TDMU with 6 elements: smart campus, intelligent people, intelligent research, intelligent administrations, smart technology, and smart influence. In the past 10 years, a digital KPCI street in Thủ Dầu Một land have never stopped rising, reaching trees to receive the earliest sunshine of the day, and all the way with the no upcoming stops. Students are the fruits of digital KPCI street with their wings, which strongly fly with their creative mind, with a sense of responsibility from the heart, and aspiration of Thủ Dầu Một University for the beautiful life.
Welcome to Thủ Dầu Một University. Spreading over an area of 5.6 hectares is a fresh and green space. Each functional area is connected by the rows of old trees, lush lawns and colourful confetti. The classroom, lecture halls and office buildings are built with a maximum of 5 floors, taking advantage of natural light.
Mình không cần trên nó mình để cái con nét này mình trao đổi với anh.
Dạ rồi cô nói cô. Thì bây giờ cô nói.
Giới thiệu luôn rồi hả?
Dạ, bây giờ cô cần nhắc em
Dạ,
cô cần nhắc người ta.
anh ơi, bây giờ là có cái cô mà giới thiệu về anh ấy, cô đang ở trước ống kính đấy. Anh chắc thử là thấy cô chưa vào để mình cùng cho phối hợp để dạ đây cô đang đứng cho ống kính rồi đó. Em chịu đi nha, phối hợp nhé. Tại em bây giờ em chạy cái một số sinh khác ấy, tí nữa em sẽ quay lại. 9 giờ bắt đầu.
Đẹp quá cô. Mình không cô thấy mình.
Dạ rồi. Dạ cô thử tương tác với lại dạ cô cứ nói bên kia sẽ nghe.
Em có thể cho mình nhìn mặt cái người đó được không?
Người đó thì
quay cái laptop em qua cho mình.
dạ hiện tại
nói bây giờ mà không nhìn thấy ai thì biết sao?
dạ hiện tại em quay là bị trục trặc từ kỹ thuật bên đây á. Dạ em nhận.
Giờ không biết nhìn vô đâu để nói dạ thầy nói.
Dạ cô nhìn lên màn hình trên.
Ok.
Thầy Lê Chí Hiếu. Dạ bên góc bên tay phải của bên tay trái. Lê Chí Hiếu.
Dạ chào thầy ạ. Cô gì mà phải quay cô. Dạ chào thầy ạ. Dạ thầy có nghe mình không ạ?
Thầy chưa bật micro lên.
Đúng rồi, micro thầy đang đặt. Mà thầy cũng không có dấu hiệu gì. Vậy là ai có cái điện riêng cho thầy bảo cho mình thầy Quang nắm số điện.
Dạ hiện tại thì tín hiệu của cô em vẫn nghe được bình thường.
Chắc là thầy cũng đang chờ đúng không?
Thầy đang chờ đúng rồi nhưng mà hình như không có nhận được.
Em điện cho cái thầy nãy nói thầy nãy điện cho thầy.
Dạ.
Dạ thầy Chí Hiếu ơi. Dạ thầy nghe rõ mà.
Còn cái vấn đề phải tính
Alo.
trả lời.
Dạ thầy Chí Hiếu ơi. Dạ thầy với đồng mình bật micro giúp em à. thầy Chí Hiếu bận rồi sao nói chuyện. Thầy Chí Hiếu che ngọn bận video lên.
Chá đi.
Dạ.
Chá.
Chí Hiếu phải bật.
Mình gọi điện cho thầy đi. Ủa chứ chá thầy không thấy hả? Thầy không nghe gọi điện cho thầy thì mình cũng không nghe được cái phản hồi của thầy. Dạ, thầy chưa mở.
Dạ thầy phải mở micro mình mới nghe được tiếng của thầy.
Okay, good morning.
Dạ thầy Chí Hiếu mới nói.
Dạ, Kim Hoa.
Anh hiểu rồi.
Hello.
Không, mấy người
Good
bên kia
morning,
bật mic
everyone.
lên.
Anh hiểu thẻ em. Mình bảo mày mình bật cái đúng không? Chắc là để nhận thôi. Sao có nắp được cái mà
Dạ cô thử mình cho nhỏ với thầy Hiếu thử.
Dạ thầy ơi, thầy có nghe được không ạ?
Chí Hiếu excuse. Hello, Dr. Chí Hiếu.
Good morning, everyone. Can you hear me?
Can you hear me? Dạ cô thử
Good
nói
night.
chuyện với thầy.
Can you hear me? Good night.
Can you hear me? Excuse me.
Hello, Dr. Chí Hiếu. Hình như có điện thoại này, cái mấy thiết bị này đang mở mic đó thầy ơi. Có thiết bị của ai đang mở mic đó.
Không, nhưng cái đọc nghe được cái cả.
Nào em muốn nghe, em không nghe được.
Cái bán.
Thì có một thiết bị nào đang mở mic đó.
Cái còn cái kia họ chưa không nghe được cả. Một cái mic của ai đang ở đó.
Dạ mic em tắt rồi luôn.
Quay trong phòng mình không biết. Ừ. Là nói nghe nè.
Có ai đang mở nè.
Có ai đang mở đó. Nó không tạm. Tắt cái mic này. Rồi, hết chưa? Còn này. Em ném thử mic chưa? Cái mic này.
Em thử thôi.
Cắm ổng không?
Ổn luôn. Dạ, nhận nó bình thường.
Tắt luôn cái máy của em.
Đâu có cái mic của bên lại là chị Bình cầm nha.
Của mình tắt luôn thử thì còn nói có cái nghe một cái báo
Thì dựng cho nó ớt rồi.
đó nó mà tắt thì đâu nghe. Nó
Chẳng nghe nè.
vẫn nghe vậy là máy của ai á?
Có ai trong phòng này mở máy nè.
Em úp cái máy chị luôn bạn không thử đi sao?
Nó mở nó sáu chiếc thì có chết. Dạ. Máy quẹo.
Ủa lên tắt luôn mà tắt hết luôn đó.
Rồi. Hết rồi.
Máy tắt hết luôn mẹ.
Kia này. Chết ra cái hỏi máy quẹo á.
Mà anh thấy em tắt mất đâu?
Không nghe được, không nghe được.
Cắm gắt mẹ bên đây.
Không, cái máy em thiết bị trúng luôn.
Thì đó ấy hôm qua một cái máy này chứ.
Hôm qua tắt máy này luôn.
Dạ.
Qua hôm qua được bình thường.
Còn bữa nay nghe chưa?
Hồi sáng em tắt bình thường.
Giờ
Hiện tại em bị nào đang mở thì sao đó?
không. Em mở sang cho cô Bình nói nghe thử là được đó.
Dạ bên đây em đang mở rồi.
Em nghe thử đi.
Dạ em nghe được rồi.
Em nghe được đúng không? Nhưng mà bên kia thì không có dấu hiệu gì là
Hỏi thử thầy chú anh mì cho bây giờ anh hiểu nhạc này bây giờ hiện nay không nghe được tất cả những âm thanh của tất cả mọi người này bây giờ xử lý thế nào đây bây giờ có thể là bên anh hiểu hay bên mình
Chứ bên mình ví dụ nói cũng nghe đúng không? Ở nghe nè, anh Hiếu không nghe được của anh. Thử pin lại coi Tâm ơi.
thì đó chị Bình nói mà nếu lại nghe được cái đúng nó đó. Hay bên đây bỏng người ta nghe được này như vậy thì bỏng được anh hiểu
Anh chỉ được quay run on Sandy đó.
hả như vậy thì anh hiểu
Vậy là nhiều nghe mà
Hello em.
không để anh đang ngồi Facebook anh đang ngồi riêng con cái platform anh không biết về đặt cái đồ về hay là do anh bật cái âm thanh lên chưa cái mute không anh bật thôi đúng không nhưng mà anh cũng không nghe được anh hỏi ở đây người ta cũng không nghe luôn.
Hello.
Mà anh cũng không nghe được bên em cũng không nghe được anh nói nhưng mà cái tất cả participant đều nghe được. Tất cả participant đều nghe được. Đấy thì để bọn check mà. Đấy. Tất cả mọi người đều bảo người ta nghe được này. Chỉ có lúc chủ âm.
Ok.
Em chắc là chắc không sao. Là anh out ra enter vào là xem.
Anh out rồi.
Hello, this is Hieu. Can you hear me?
Bây giờ nghe anh thôi này. Ok, nghe rồi.
Hello.
Vừa mới nghe xong. Anh ở lại đi sao?
Okay. Good morning, everyone. Can you hear me?
Okay.
Như
Yeah, can you hear me, everyone?
Chị cứ đứng im miệng nói quay thôi. Còn chị đứng ngay một.
Okay, Dr. Bin, can you turn on the microphone?
Chị đứng ngay một quay.
Can you turn on microphone, Dr. Bin?
Rồi. Okay.
I cannot hear Dr. Bin.
Anh Thảo ông mở bích lại. Anh liền. Tắt xong cũng mở hoài. Ủa sao không nghe ta?
With the aim of creating a domestic and
I cannot hear anyone.
Hello.
There may be someone turn off the microphone. So Tina, can you turn on the microphone?
Chưa chị bật đó. Chắc phải nó lại. Cái máy này cái đầu cắm hình. Rồi.
Hello.
Alo. Nghe được chưa? Okay, thank you. Good morning, everyone. With the aim of creating a high-quality academic exchange forum among scientists, as well as domestic and foreign experts on recent improvement, future trends, and intelligent computing research on various technical fields include electrical, electronic, mechanics, and information technology. Today, June the 3rd, 2020, Thu Dung Mộc University is honored to cooperate with Kalinga Institute of Industrial Technology to host the 5th International Scientific Conference on Research Intelligent Computing in Engineering 2020. The 5th International Conference on Research in Intelligence and Computer Engineering, RISE 2020. RISE 2020 will be held the 5th international conference, followed by the 4 previous conferences successfully held in Nagpur, India, March 2016, Ostrakhan, India 2017, El Salvador 2018, and Hanoi, Vietnam 2019. This conference is hosted online via Microteam applications. In order to clarify your knowledge as well as how further research on issues raised by the conference, the Content Committee has divided the conference into 7 subgroups as follows. Section 1 Smart Manufacturing Industry 4.0. Chair Dr. Hieu, Dr. Anh My Chu. Session 2, Deep Learning for Intelligent Systems. Chair Dr. Bùi Thanh Hùng, Dr. Rakhavendra Kumar. Session 3, Artificial Intelligence and Machine Learning. Chair Associate Professor Lê Tuấn Anh, Dr. Brocho Kishore Mr. Session 4, IoT, a core system and application. Chair Dr. Nguyễn Văn Tâm, Dr. Suvit Pant. Session 5, Signal Processing and Network Communications. Chair Dr. Nguyễn Hà Duy Cường, Dr. Rashmi Arawant. Session 6, Advances in Modern AI and Healthcare Applications. Chair Dr. Hoàng Mạnh Hà, Dr. Manju Khari. Session 7, Wireless Sensor Network and Applications. Chair Dr. Hồ Đức Dũng, Dr. Prasan Kumar Patnaik. Thank you.
Hello on. Hello on. Hi. Can you hear me? So now it's your turn with you. It's your turn. And one thing is very important. Please, on the participant, please turn off your microphone, please, because if not, it's we will confuse of the echo. So please, it's your turn, Mr. Hieu. It's it seems that Dr. Hieu, please turn on your microphone, please.
Okay. Okay.
Now, okay. Thank you.
Okay, Dr. Bin, can you start your presentation now? So everyone have about 10 minutes for the presentation maximum, and 1 or 2 minutes for the question. Okay. So if anyone have the question, can you send your question to the tab post here? So I know how to mention you to provide question for the presenter.
Hello, good morning, everyone.
Hello.
How are you?
I'm fine.
Okay, so paper presentation is started.
Yeah, we start the first presentation now. We are waiting for Dr. Bin to.
Dr. Bean, I can
yeah.
see he's online and he's putting effort best to start the presentation. Yeah. Good morning, Bean. How are you?
Yeah, everything is okay. In the UK, now it's 3 o'clock in the morning.
No problem. We are 24-hour format, sleeping and waking up. You please start.
I hope I can stay awake for another 3 hours.
No problem.
Yeah. Dr. Bin, can you share the screens? What is the problem now? First of all, you should turn on the voice, the mic, microphone. Dr. Bin, you can go to the data, to the file, and open your presentation in Team. I uploaded your presentation already. Yes. Okay. Okay, you can start now, Dr. Bin. So everyone should upload the presentation into the Microsoft Teams so you can start doing presentation directly from the Microsoft team. It means that you don't need to share the screen.
Hello, Dr. Bien. Can you see? We can't hear from you. It seems that you don't have microphone. It seems that. Please check it again. Dr. Hieu, can you hear from Dr. Bien?
No, I hear nothing from
Yeah,
Dr. Bien.
because I seen in the screen there's no microphone of the Dr. Yun Sung Bien. Please check your microphone. Please check. We can't hear you now. Or you can try the other computers, please. Thank you.
Can you hear me? Từ cái này ra.
Dr. Bin, we cannot hear everything from you. You should turn on your microphone. Can you check this?
Microphone. Can you hear me?
We can hear you now.
Can you hear me?
Yes, we can hear you now. Yeah.
Yeah, I start now. Rồi. Okay. Nó bị vọng rồi. Okay, can you hear me? Được rồi đấy.
Can other partner turn off your microphone? Only the presenter turn on the microphone, and then there should be no problem with the echo voice. Dr. Bin, can you? Okay, Dr. Bin, can you start your presentation now? I think it should be okay.
Can you hear me?
Yeah.
Okay, thank you. Yeah, I start now again.
So the title of our report is Inverse Kinematic Analysis of Wearing Robots Using Algorithms for Adjusting in the Increment of Generalized Vector. Our report includes some major contents. The first, some information about the wearing robot. The second is the kinematic modeling. The third is the algorithms for show the inverse kinematic. And then I show you some results for examples, numerical simulations. And last but not least, I have some comment in conclusions. Can you hear me clear? As we know, the inverse kinematic problem always play an important role in modeling robot and design control systems. We have many methods to show the inverse kinematic. For example, we have the Jacobian transpose, residual inverse, closed loop inverse, and etc. And in this output, we present the algorithms for adjusting the increment of generalized vectors. We calculate the position, velocity, acceleration, and rate of joint of wearing robot. About the kinematic modeling, we have the diagram on the left on the slide. We have 6 degrees of freedom of wearing robots. All joints are rotational joints. We build the kinematic DS parameter matrix. We build the forward and inverse kinematic equations with generalized vector Q from Q1 to Q6, and the vector in workspace X includes XE, YE, and ZE. Because these systems are the redundant systems, we must be calculate the residual Jacobian Z plus. You can see on the 12 formulations. About the algorithms for solving the inverse kinematic, we use the algorithm for adjusting the increment of generalized vectors. We have some parameter, initial parameter, the time and the number of steps and the value of each step density. And we have the initial vector Q at t equals 0, and we calculate the the value of positions, velocities, and accelerations and rates of the joints of wearing robots. And on the right of this slide, we have the diagram for it shows the algorithms for adjusting. And we have the example numerical simulations. We have some parameter of geometry of wearing robots. We have the limit values, maximum velocities, maximum accelerations and rates. And we have the design part of the ineffective point. It means task equipment of the wearing robot. We have the error value with epsilon. You can see on the slide. We have diagram for calculations of algorithms. The first diagram you can see on the slide is value of joint positions of 6 joints of wearing robots. And the second and third and last, we have the velocity, acceleration, and jet respectively. Then we have the value of deviations between the designs and calculate. You can see on the diagram between at the middle. And in the MATLAB software, we have robot simulations. You can see on the slide. So about our report, we can solve the inverse kinematic problem of 6 degree of freedom wearing robots. This is the new type of robot of ABB comparisons, and we are adding an effective inverse solution for redundant Stellarian robots. And in this paper, we can share the algorithms also apply effectively to other type robots. For example, the mobile robot or parallel robot, and you can use some type of robot for welding, cutting, and 3D printing, and in the both time domain and parametric domain. And thank you for your attention.
Okay, thank you for your presentation, very quick presentations. Anyone have any questions related to the presentation of Dr. Bean? Can you mention, if anyone don't have any questions, so can you mention a little bit about the future study? It means suggestion for future study or related study, or any kind of project related to this study, so others know what you are going to do in the coming time, or some potential cooperation. Dr. Bean?
Yes.
Can you hear me? Yes. You
Please give me the questions.
Yeah, no one have any questions, so I just mentioned that you may explain a little bit about the future studies related to this paper, and what is the research project related to your presentation now. So some other know how to collaborate with you. Yeah, we can stimulate some potential cooperation related to your study.
Yeah, in the future, I think I can use this the algorithms for inverse kinematic problem. It's very important when we solve the inverse kinematic for robot in Stellarian robot. We can use in some applications about the welding, cutting, and 3D printing, and collaborations between the machine, computer numerical control machines, CNC machine, and we can combine with arm manipulator and CNC machine, and use these algorithms for that. I think it's very possible.
Okay, thank you. I think we can start the next presentation. So if anyone have any questions, so you can post your question in the meeting chat. Yeah, so we can chat at the end of our session. Okay.
Yeah, I share the next report.
Okay.
This is the second of our report. Optimize the fit rate. This is the important parameter when we use the robot in machining. We optimize the fit rate of 6 DOF robot in parametric domain.
Can you share your new presentation, because I cannot see your presentation.
Yeah, we have the same the first and second slide. The other slide, other report.
Yeah, but at the moment I can only see the first slide, the first presentation.
Yeah. You can see the second presentation.
No. Can you close everything and then open the new one? Yeah.
Yeah.
Okay. Can you open the new slide? Yeah.
Yeah. Yeah.
Okay.
Yes.
Okay, now you can start your presentation
Yeah.
now. Yeah.
The title of next report is optimize the refit rate of 6UF robot. It's the same robot on the first presentation, but we can calculate the fit rate parameter in parametric domain based on the kinematic modeling. It's a true problem. And the first we can we know the robot are wiring in wearing machining. I mentioned above in cutting machining, printing 3D, and editing manufacturing, and the demand to reduce the time cost and increase the manufacturing is very important. And the issue of optimizing the production process is very, very important, and we must be concerned. In particular, optimize the fit rate parameter is the most important between some parameter when we machining. And in this paper, we present the method to optimize the fit rate parameter when we use the robot with 6DOF in the parametric domain based on the toolpath profile given. The first, we calculate the positions and velocity and accelerations and just in parametric domain. Based on the definitions of S parameter is the art of Q. This Q we are given before. If not that, we calculate some parameter in parametric domain. We have some formulations from 6 to 8 formulations, and this is optimal algorithms. In this slide, I want to talk about the two algorithms. The first algorithm is the optimal, the fit rate parameter. The second is the algorithm for adjust the increment of generalized vector. I mentioned about the first presentations. The diagram on the right of this slide, we have the optimal algorithms. We start with initial parameter, the Q, or we can talk about the toolpath of an effector point of wearing robot. We have the initial fit rate parameter, maximum fit rate, and the increment of fit rate, and maximum about the position, the velocity, acceleration, and jet. You can see on the left of the slide. The constraint conditions when we use the optimal algorithm. The output data, we have the fit rate, optimal fit rate. This is the results of numerical simulations. When we have the design toolpath, such as the Bezier cube in a parametric domain, X used with 4 positions on the workspace, and we have the arrow value. And because I use the real robot in our factories and show the actual wearing parameter we use in real time, it's Q0, and maximum the velocity, acceleration, and jet. This is the real parameter I use on our factories. And this is some picture about the numerical simulation on the MATLAB software. This is the result when we calculate the value of joint positions, velocity, accelerations, and the most important result is the value of optimal fit rate. We can calculate the optimal fit rate parameter for each point, each position on the workspace along to the tune path. You can see some code for the wearing robot X, Y, Z, and F fit rate. And in general, we can calculate the position, velocity, and some parameter in the parameter domain based on solving the inverse kinematic problem. And we have the algorithms for optimal fit rate values. And the last, this paper is very meaningful for programming the optimal machining for complex tune parts and contributing to reducing machine time cost and improving productivity. And I think it's so good for when we use this optimal algorithms. And thank you for that attention.
Okay, thank you for your presentation. So anyone have any question?
We have two algorithms.
Okay, I have the question for your presentation. So this is applied for the robot, yeah, 6 degrees of freedom. So if you can apply the same approach and methods for 5-axis or 3-axis CNC machine? It's similar like this?
I think so, because if the CNC machine with 3 axes, 4 and 5 axes, we can understand it is combine the two arm of robot. We can understand that table of machine and the spindle machine and some axes. We can apply these algorithms for CNC machine with 3 or 4 and 5 axes. I think it's very easy.
There are also potential for application for 3D printing, especially some technology linked to fuse deposition modeling.
Yeah.
I think you can apply the same principle. I think we can you can extend the application to the field of additive manufacturing.
Yeah. In the future. Yeah.
Okay. So, I would like to share more information about the project Dr. Bin presented. So if anyone interested in this kind of project, because this project is funded by Newton Fund, you can see here, it's a British Council Newton Fund. The project funded from UK government. And also we have 2 projects funded by Vin Group linked to smart manufacturing and Industry 4.0. So if anyone interested in this area, you can contact Dr. Bin for future cooperation. Yeah. So the next presentations, if you don't have any questions, so we can start the next presentation. Yeah, the next presentation for Dr. Van Kang. Yeah. Fuzzy logic simulation for classifying abrasive wheel in pendulum grinding.
Hi everyone. Can you hear me?
Yes, we can hear.
Yeah.
Can hear you. Can you share your screens?
Sorry about my webcam is not working, so I use my microphone to present my talk. The paper is original is Nguyễn Văn Khánh is the presenter, and now I'm Nguyễn Văn Thân from it's called co-author and present this work. I'm from Ngô Quyền University, and the title of my talk is Physiologic Simulation for Classifying Abrasive Wheel in the Pendulum Grinding. The outline of my talk is introduction. Second, statistical and fuzzy analysis of experimental data.
Mr. Kwon, can you share your screens? Can share your presentation, yeah.
Sorry?
Can you share your presentation slide? Yes, so everyone can see your screen, yeah. We can see you, but we would like to see your presentation.
I open it the file.
I uploaded your file in Microsoft Teams, so we can open directly. Yeah.
Yeah. You
can see.
So, is this okay now? Can you?
Not yes. Can you click on share, screen share? You can see the button share. Okay. You can see here. Okay.
It is working. Sorry, is this working? Can you see the slide?
Not yes.
I open this, but
you have to click on the button share.
Where this button?
You can see it close to a microphone or camera. You see the button it share screens. I think Dr. Bean should stop sharing the screen so others can share, maybe.
I stop share. I'm not share.
So sorry, can you see the slide?
No, not yet.
What?
Dr. Bin, can you stop you share a screen share so the other can share?
Yeah, I stopped a long time.
Oh, there it yes.
It's still working.
Yeah. I think we can see now. Maybe
yeah. Sorry about it.
Okay, you can start your presentation now.
Yeah.
Thank you.
And the outline of my work, my talk is the 4-part introduction, and the second is the statistical and fuzzy analysis of experimental data, fuzzy logic modeling and discussion, and final is the summary. First, introduction. The classification is set of machine learning problem in which an input is classified into different classes. It can be either supervised or unsupervised. One of the problems in the grading field is classify the abrasive wheel. The reason of the problem is the many abrasive wheels are produced. So the second is output process so many. And besides that, exercise of classification of abrasive wheel according by output of process is not considered by manufacturer. Approach for solving this problem is doing the machine learning. Now there are many methods of the machine learning can solve this problem in the slide. The purpose of this study is to find the wheel that has best cutting capability in the formation of surface topography of material with the involvement of fuzzy logic, reduce fuzzy logic, and it leads to the improvement in the quality of assembly of cutting tool and its durability. This is the experimental and method. The natural experimental was shown in the slide, and the condition green, condition green. The grinding machine is T-71 and we use 16 abrasive wheel. The experiment amount 30 times, and there are variable of research. There are 6 parameters, include roughness, RA known as YE, and maximum Y2, SM, Y3, and the variable accuracy form and other micro hardness. With the measure of position and this person, we have 12 input for each operation wheel. And the statistical method for selecting input for process described the structural scheme. We test hypothesis HO H0 about homogeneity of dispersion and normal distribution. Its experimental data satisfy 2 conditions simultaneously. Then we do parametric method with the variable of mean, range, and standard deviation. And otherwise, non-parametric method is used with variable median and quarter width. And in this slide, we propose fuzzy logic control of classifying abrasive wheels. This is through fuzzification. It is any numeric value is taken as input to falsification. It changes the numeric value into fuzzy quality and give them a suitable set according to their degree. Knowledge database. There are some informative data in database. It tells about the definition of membership function which applicable in rules of fuzzy logic. And rule based. There are different set of fuzzy logic which contain different conditions such as if and then. The rules are determined after a long practice done by the skilled person. And if you falsification, this is mathematical express are due to change the fuzzy quality into numeric value, and this mathematical expression gives numeric value as a result of output after number of operation, and the final is the output. It takes the decision by doing the condition if and then in order to change its numeric value to in fuzzy quality. This is the model of fuzzy logic with the model R is the fuzzy rule, and A is the effective object. C is degree of true condition, and L is the true degree of particular solution of the rule. And F for the class object. Y is the membership function of the subclass for the rule. S conclusion of a fuzzy classification system, and T the output. This is the initial data of experiment after statistical analysis, and this is in the classification state. Experimental data was divided into 3 ranges: it's good, middle, and bad. This shows a layer 2 of fuzzy system controller for 2 variables, and median and QW. The number of rows is 9. And when for the 6th variable, we have 729 rows. And this is the review of the modeling we're showing in the slide. Result of modeling at the first stage. In this stage, we can choose optimal value for each parameter of survey quality. For example, RA, we can choose 1, 2, 5, or 6. And this is the result of second stage. We can show the modeling of fuzzy logic under the condition of integral assessment state survey has classified cutting capacity of abrasive well into 3 groups. It is good, normal, and low. And summarize, it is shown that uses of fuzzy logic simulation will be effective tool in the classification of cutting capability of abrasive wheel. And, so thank you for your attention.
Okay, thank you for your presentation. And anyone have any question?
Sorry, because this is Dr. Nguyễn Văn Cảnh will answer all the question, and the question can send to his email, and he can answer by email.
Okay.
Thank you so much.
Okay, if anyone have the question linked to the presentation of Dr. Kang, and then you can send the question in the meeting chat menu. Yeah. Okay. Dr. Kang, can you stop screen share?
Okay.
Okay, I just have very small question for Dr. Kang before we move to Dr. Bin or Dr. Chu Anh My for the next presentations. No, I think the next presentation is Dr. Hieu.
Yes.
Yeah.
Can you hear me?
Yeah, I can hear. I can hear
Yes.
you now. Yeah.
So I would like to share my presentation. Do you see my presentation?
Okay, I can see. Yeah. Okay. Good.
So okay. Hello everyone.
Yeah.
Hello everyone. My name is Nguyễn Trần Hiếu from National University of Civil Engineering, Vietnam. Today I have honor to be here to share with you some interesting results concerning a comparison of machine learning algorithm in predicting the behavior of church structure. So this is the outline of my presentation. First of all, I would like to introduce the reason and the purpose of the research. In the second, the research methodology is briefly present. And the third part focus on two benchmark problems that were used for the comparison study, the data generation process as well as the hyperparameter process I also present. And the result of the comparative study are summarized in the fourth part, and finally some conclusion I point out before terminating my presentation. So now let's start. First of all, let me introduce myself. My name is Nguyễn Trần Hiếu. Currently, I'm a PhD student of National University of Civil Engineering in Hanoi, Vietnam. My research focuses on the application of evolutionary algorithm and machine learning for optimization of steel structure. In recent decades, many evolutionary algorithm has been proposed and successful applied to solve structure optimization problem. However, the structure optimization problem are classified into the constraint type, in which the candidate must be satisfy some structure condition like straight condition or displacement condition. So for the large scale structure, the constraint must be checked with the help of with the support of the finite element method. So this is the most time consuming term. So one effective solution to deal with this problem is the use of machine learning to predict the behavior of structure instead of finite element methods. So the question here is which algorithm is suitable to capture the behavior of structure? This is the motivation for conducting the comparative analysis. As you know, data is the most important component of machine learning. Some previous study data through experiment, but it is impossible for large scale structure like choices. So to deal with this problem, some study use result obtained from parametric finite element analysis as the training data. So this is a flowchart for building a machine learning model in this study. Firstly, the Latin hypercapsampling method was used to generate the input data, and the response of the structure received from the finite element analysis such as straight as well as displacement is considered as output data. So after that, the process called hyperparameter should be implemented to find best parameter for machine learning model. The finite model is then trained with the full training data set, and after this step, the machine learning model is ready to predict on new data. So in this study, we carefully selected 6 regression algorithm for comparison, including linear regression, k-nearest neighbor, decision tree, random forest, support vector machine, neural network, and AdaBoost. So the performance of selected machine learning algorithm are measured through 2 benchmark problem, including the cantilever 10 bar choice and the spatial stratified bar choice, with the assumed mechanical property as shown in the slide. In both problem, 2 data set named training and testing data set are also generated, in which the number of data point in the training set and the testing set are 1000 and 200 respectively. So this is an example of the training data set for 10 bar choice problem, in which as you can see, the input is as the cross-section area of choice member, and the output displacement obtained from finite element analysis. So the hyperparameter turning process was performed using the combination of the research algorithm and k-fold cross validation, with where k equal 5, and the parameter of the machine learning model after hyperparameter process are summarized in table 1 as you see in slide. In this study, 2 performance indicator used for comparison as the mean square error and the coefficient of determination. Besides, the computation time is also described to evaluate the speed of training of each algorithm. So each problem is independently performed for 10 times, and the average value is reported in table 2 and table 2 for 10 batches and table 3 for 25 batches. As you can see in the slide, the AdaBoost model has a highest accuracy, followed by the neural network, random forest, support vector machine, k-nearest neighbor, and linear regression. However, the AdaBoost have largest computation time. So to prove the effectiveness of the AdaBoost, it will compare with the existing work from literature. It's seen from table 4 that the mean square value obtained from the AdaBoost model is lower than remaining value. It means the performance of AdaBoost is better than other. So after comparison, some conclusion is point out. In this present study, machine learning algorithm was used to predict the displacement for 2 problems of 10 batches and 25 batches. Overall, the result of the study proves the capability of machine learning in predicting the behavior of just structure. And the comparative analysis shows that our the 6 common regression algorithm, the AdaBoost algorithm, has the best performance, but it requires a lot of time for training. So the neural network algorithm is also recommended because of its high accuracy and low computation time. So this is some brief result of my research. Thank you for attention.
Thank you very much, Dr. Hieu, for the presentation. So anyone have any questions for this presentation? My first question is, I saw the logo of Vingroup Innovation Foundation. So this project is funded by Vingroup?
Yes. So as you can talk before, actually, I'm a PhD student, and my research is funded by Vingroup Innovation Foundation.
Okay. Yeah. Thank you. So my question linked to the data training says, so this is the data you generated, or it's from the other, so you generate this data, yeah?
Yeah. The data is generated. Firstly, the input data is generated using the latent hypercapsampling. So after that, the output data is received from the finite element analysis. So after that, the input and output is combined to training data sets, and it fit to machine learning model.
Okay, I think it's quite new area, and this can this data set be standardized for some other
Yes, of course. Yes, of course. Before training on input is normalized, so the input data is range from 0 to 1.
Okay, so I think on the right side, so you get output from finite element analysis. So this is it's done by standard algorithm, or can you use this one from the other software, commercialized software?
Yes, I use commercialized software. The software I use is SAP 2000.
Okay.
Yeah.
So what is the next step for this study?
So after building a high accuracy machine learning model, I will use this model as a surrogate model in evolutionary algorithm to reduce the optimization time.
Okay. I think your problem is quite big problem, because it linked to construction area.
Yeah.
So if you can focus on typical problem, it might be better for the typical case study before you can apply to the big problem.
Yeah, I hope that.
Yeah, because finite element analysis still a lot of error from finite element analysis now.
Yeah.
So in theory it's correct, but in practice you need a lot of validation from experiment.
Firstly, my research still limit in some benchmark problem, and you can see some sample structure. But for the large scale and complex structure, it's very complex, and it's quite difficult to apply machine learning in such structure.
Yeah, that's why I mentioned that you need to focus on very simple case of finite element analysis before you go to very complex problem like this one.
Yeah.
I think it's very interesting research.
Thank you.
Okay, thank you. If anyone don't have any question anymore, so we can start for the next sessions. So the next presentation is from Dr. Lê Văn Thảo, a presentation about additive manufacturing, 3D printing.
Yes.
Yeah.
Can you hear me?
Yeah, I can hear you. So can you share the screens?
Okay. So allow. Could you allow me to share my screen?
You can see the share nose very close to microphone and
but now it's not active.
So can you upload your presentation to Microsoft Teams? I think if you upload, and then I'm sure you can present directly from Microsoft Teams.
Okay.
You click to the file and upload.
Yes. Upload. Micro team. Upload rồi. FSS class. I can. How can I upload my presentation? Đã gửi cho họ đáp lên đây. Team I okay. Yes. Okay. Cool. Lúc trước anh làm kiểu gì?
Anh chỉ bật, anh share màn hình rồi bật lên thôi.
Anh không có share màn hình.
Anh share màn hình của anh xong rồi anh bật cái quen lên nhé. Đây có bài 82, 83 nhỉ?
82. 83. Maybe I will train my computer to present my work. Để tắt cái này đi.
I can see your screen now. Okay.
You see my presentation?
Yes, we can see it now. Thank you. We can start your presentation now. This is how.
Okay, thank you very much. Hi everyone. I'm Lê Thảo. I'm researcher at the Advanced Technology Center of Liquido Technical University in Hanoi, Vietnam. So today I would like to introduce you our work on additive manufacturing of thin wall steel parts by gas metal arc welding robots on the shape, microstructure, and mechanical properties. So, what is additive manufacturing? Additive manufacturing has been emerged in 1980s, which allow us to produce a physical part by adding material layer by layer. So, the main advantage of AM are the freedom in design and manufacturing. That means AM can produce the parts with very complex geometry. Additionally, because of the principle of layer manufacturing, we can save the input material used to manufacture the target parts and reduce material waste as well as the environmental impact. Nowadays, AM, in particular metal AM technologies, are used efficiently in different sectors, for example, aerospace, automobile, and biomedical engineering. Beyond the heat source used in AM, metal AM technology can be classified into laser AM, electron beam AM, and wire AM. The heat source in wire AM can be gas metal arc welding or gas tungsten arc welding and plasma arc welding. In comparison to other metal AM, wire additive manufacturing show a high deposition rate, low cost of production, and equipment investment. In addition, the use of metal wire as the feed material is safer to operators and the environment. The manufacture of parts by wire additive manufacturing, can you see here, can be performed by a robot or a CNC machine. So this technology is more suited for manufacturing large dimensional components. So in our work, we are investigating the effect of the deposition strategy on the shape of thin wall and the microstructure and mechanical property of the thin wall. In our study, we use the low carbon steel as the feedstock and low carbon steel SS400 substrate to build the thin wall by an industrial welding robot. During the welding process, we use a gas of 99.99% CO2 with a flow rate of 15 liters per minute for the soldering. To investigate the effect of depositing strategy on the shape of thin wall, we consider two following strategies. The first one, the deposits were performed in the same direction with a holding time of 60 seconds. And in the second one, the deposits were performed in two opposite directions with the same holding time of 60 seconds. And we use, the parameter to build the thin wall. Once the most suitable strategy was chosen to build the thin wall, in the first stage of our research, a thin wall were built for observing the microstructure and mechanical properties of the wall. Here, a specimen was extracted from the middle region of the wall for observing microstructure and for the handed testing. And we also extract 3 tensor specimens in vertical direction and 3 tensor specimens in horizontal direction for testing the mechanical tensor property. Especially observe that the alternating deposition direction strategy is the most suitable one for the build of thin wall with more stable shape. The thin wall show relatively regular height in comparison to the wall built with the first strategy. So in our study, we use the alternating strategy for the build of thin wall. Here you can see the typical microstructure of the wall built with the alternating strategy. The microstructure of the wall can be classified in 3 regions. The upper region shows laminar structure of Paris, can you see here? And the middle region shows the granular structure of Paris with small amount of checklist of grain boundaries of Paris. And here you can see also his affected round between two layers with the grains more coarser than the non-heat affected zone. And in the lower zone region of the world, we can see the mixed lamellar and aqueous structure in microstructure. The handles of the world also change from region to region. The upper region shows the highest value of hardness, and followed by the lower region and the middle region. And we also find that the average value of tensile strength in the vertical direction that are higher than 0 in the horizontal direction. So the main conclusion of our work can be highlighted as follows. The alternating direction strategy allows thin wall with more shape stability and regular height to be viewed. And the microstructure of the wall vary from the top to the bottom region and can be distinguished in 3 regions. Lamellar structure in the upper region, granular structure in the middle region, and mixed lamellar and aqueous grains in the lower region. Finally, the welding robots can be used to manufacture low carbon steel components that are adequate for real application. Thank you for your attention.
Okay, thank you, Dr. Van Thảo, for the presentation. If anyone have any questions, please present your question to Dr. Thảo. So if I have a few questions for Dr. Thảo. Yeah.
Yes.
The first one is what is the minimum thin wall thickness that you can produce for this kind of technology? Minimum.
Sorry, can you repeat your question?
Yeah. What is the minimum thin wall thickness that you are technology for 1 millimeter or 2 millimeter for the thin wall?
Keyword?
Yeah. You know the size, the thickness.
The size.
Yeah, the thin wall.
The size of the thin wall.
Yeah, the size.
Yeah. It depends on the weight of the welding bed, and the welding bed depends on the parameter you in the welding process. For example, the width of the bed will be decreased when the travel speed of the welding tops increase. So when the travel speed is too high, the welding bed is very narrow.
I think for they study the texture, the surface quality is not good, yeah, because the light is quite high. It can be only
It's commonly observed in the wire additive manufacturing. In fact, the side surface of the wall should be machined to reach the quality requirement.
Okay, so you need some post processing operation.
Yeah.
Okay, so the other question is linked to, I know this technology now very popular for symmetrical parts because it's very difficult to control the machining parameter. So why you research study focus on very complex parts?
Now it is the first study in my project on the using wiring robots for additive manufacturing purpose. The first time we would like to confirm the feasibility of
technology.
This technology for the build of parts. After that, we will manufacture the more complex parts.
Yeah.
And in addition, now we use an industrial robots in our institute. It do not allow to program the complex parts for the deposition. Now we develop an algorithm to slicing the path and then generate the wiring path for the build of the path. So that we will do in the future work.
I think for this kind of project, the advantage of this project is you can make very big parts, big size.
Yes, exactly.
The second thing is you can make the metal part. It's in like rapid manufacturing, but there are a lot of challenges linked to the quality of the surface texture and also for the control. You know, the parameter like this one. That's why the company focus more about symmetrical. You know, they control by rotating. Like turning machine or something like that. So they can make very big part.
Yeah.
Okay, interesting research. Thank you, Dr. Thao. Yeah.
Thank you very much.
I think you should collaborate with Dr. Bin for the project link.
Yeah, we are in the same team in our university. Okay, thank you.
Thank you. Okay, for the next presentations, we have presentation from Dr. We have one presentation from Dr. Sama. Dr. Sama, are you here? I cannot see you here. So I think we can start for the next presentation. Dr. Tang?
Yes.
Are you ready? Yeah?
Yes.
Yeah, okay. If you are available, if you are ready, you can start the presentation. So Dr. Tang, you're going to present about the topic linked to development of a stimulated model for smart manufacturing using the Internet of Things and industrial robots, integrated process line. So you can start sharing your screen. Thanks.
Screen. How can I share the screen on Microsoft?
You see, if you can see three icons close to the icon close to the microphone. Big, yeah, it's the share icon. So you can click this one. You can see your presentation or share screens.
It said only the meeting organizers and research
Okay, so in this case, can you go to can you upload your presentation and then you can open the presentation? I'm sure you can see. So we go to session. Can you see the file?
Yeah.
You go to the main session and then upload your file. So I can share the screen so you can know. If you don't know how to do, I can share the screen. I can show you.
Yes, please.
Okay, so I share the screen so I can show you how to do. Yeah. Okay. So I share the screen here. Okay, if you go to this one, you see here the file. So you can upload your file here. You click upload. Yeah.
I cannot see. Yes, I cannot see the screen.
Can you see my screens?
And no, it's on Facebook now.
Okay, you can send the file to me in Facebook or any link you can send so I can upload for you. It's here. I think I can or I can show the diagram, the picture, so you can understand. You can see. Yeah. See here. So if you go to meeting chat, so I can see. I send you the photo, the figure, how to upload the file. Yeah.
Người ta upload. Cloud Store. Google Drive. Check out. Google Drive. Anh đang Google Drive sẽ.
So if you can upload the file, so I'm sure you can open the file in Microsoft Teams. You can upload the file directly in meeting chat. Yeah.
Meeting
yes.
chat.
Yeah. You go to meeting chat, and then you can upload the file. So I can upload for you if you don't know how to do.
Yes, I upload the presentation on the chat.
I think you can open new file.
Yes.
Double click. I'm sure you can see. Yeah. Yes. Okay. You can see now. Okay. Good.
So.
Excellent. Okay. So you can start your presentation.
Yes.
Thank you.
Thank you, Dr. Hieu. We are from GPM of VGU, and our paper is on the development of a stimulated model of smart manufacturing using the IoT and industrial robot integrated production line. So because the specification of our course, our program, we focus on the application of the available technology into the production. So our paper will focus on that matters. Here's the content. First, we go through the short abstract and introduction and our work, our setup. We set up the experiment to test, and then there's a result, conclusion, then some further development of the topic. So for the abstract, we would say our paper is to develop a production line in footwear industry using the IoT and industrial robot. The process go through conceptual design and developing a prototype. Then we make a control software and using the PLC and HMI for controlling. We also use the Arduino microcontroller for the robot, and finally we assume the prototype and the system is applied with the IoT. First of all, for introduction, like how we come up with the idea, the concept, we would say that automation have a huge advantage on production. Like we list here, reduce the labor cost, reduce operation cost, and reduce the number of equipment in production line. And then we have IoT and industrial robot, which can help with the automatic production line in manufacturing, and all of those can improve the overall equipment effectiveness. So our purpose is to develop a models of IoT and industrial robot integrated production line for training and education in our lab. Here's the low fidelity prototype which we make in the lab. First of all, we make the conveyors. We have 2 conveyors. Then we have a buffing machine, which can be anything. So we make a bell grinder, and we make a small SCARA robot arm for simulating the process of grinding. Here is our block diagram, our flow chart. First, we put the object on the first conveyor. Then, when the conveyor is in position, the robot arm will pick the object and process on the bell grinder. After the robot arm finish the job, it will drop the object on the second conveyor, and the second conveyor will stop at the good position for pick up or drop on another transporter. Then we have our experiment setup. Here we testing the crippler and the object, which is the boxes. And here's the experiment setup of our prototype. Then we apply the IoT to our prototype. We use the module of ESP 8266 to send the data to ThinkSpeak, and we have the database, the experiment result, which shown that our productivity can be improved through using this prototype. So we conclude that with the industrial robot, the production line can provide low cost and effective process for manufacturing and also for factory planning. Then after we apply the IoT technology, we saw that the manufacturing system can be managed easier, and data collection would be also easier. So the application of IoT support the managers to analyze the database and can make the corrective action or to assist with the decision making in production process. So here's some future works which we propose is the professional training solution for technical employee with the automatic manufacturing system in factories. And then this model is also for educational purpose, which help the graduate student working in the field of automation and IoT applications. So we propose to apply this model. Then therefore we make we saw that the model have an important role in developing the future concept of smart learning factories and industrial 4.0 in the near future. So in further research, people can have deeper study in this model to apply the IoT or smart factory. So this is the end of our presentation. Thank you for your attention, and please ask a question if you have.
Thank you, Dr. Thanh, for presentation. If anyone have any questions, please present your questions. So can you, if no one has questions, I have a question for you. Project, are there any grant funding for your project? Research project? Is the internet funding from university or any academic funding?
Yeah. I'm sorry, but can you ask again? The connection is not good.
Do we have any grant funding for your research?
Yes,
funding from university or funding from another funding body like now for stage, Vincru.
Yes.
For the other funding.
We have the funding from our university research development department. They provide the budget around. Yeah, so we just use the funding from our research department.
Okay.
Yeah.
So for this kind of research, so what is the device or Internet of Things? You also develop everything, or did you buy some equipment of Internet of Things or other device to integrate for your manufacturing system?
Yes, for the device we use the module which send the signal to the to ThinkSpeak, and then we also have a receiver to get the signal from ThinkSpeak.
Okay.
But I would recommend using the phone device to easier to control.
Okay. Do you plan to apply 5G technology for the control?
Yes. At the moment, the technology is not really good if it come to mass production because of the delay time. So if we can apply 5G to IoT, I think that would be a huge advantage.
We have a few projects linked to this one. Our research group in Vietnam is that got one grant from Vingroup. It's about I think a quite big grant to work on this kind of thing, to use collaborative robot with Internet of Things for smart manufacturing. So if you are interested in this one, so I can share a few research with you later. Okay.
Yes.
It's an interesting topic. Yeah. Okay. Good. Thank you. So we can start for the next presentation with Dr. Hồng Quang. Topic is reinforcement learning-based adaptive optimal strategy for robotic control system. So Dr. Hồng Quang, are you here? I cannot see Dr. Hồng Quang available for the presentation. So if Dr. Quang is not here, we can start another presentation from Dr. Chuan Mi and Dr. Bin. Dr. Bin, are you ready? Are you available? Okay, Dr. Bin. Dr. Zung Sun Bin available. Can you start your presentation? Because Dr. Hong White not available. Can you turn on your video also? Yeah, so everyone can see. You should also turn on your microphone.
Yeah, I'm ready. Can you hear me?
You can start presentation, Dr. Bin.
Yeah. Can you hear me?
Yeah, you can hear.
Yeah,
You can
thank you.
now. Okay, you can share.
Yeah. Hi everybody. I will present out the report because of Dr. Chuang Mi is so in business and I recommend to represent his report. The title of Code Effective Solution for Integrations and Control of Robotic Cells in Hot Forking Industries. The first, I want to present the mechanical system of a robot, and the second is the design, the control systems, and then is the validations and testings of the product when we fabricate this, and we have some comment on in the conclusions. This report presents an effective technical solutions for integration and control of robotic cell in the hot press forking industries with two tasks. The first, design the robot to support the worker for moving the hot and heavy billets workpiece from the furnace and design a hydraulic press machines. And the second is we design the control system for robots. We design the robot with four tasks. The first is the move workpiece at the loading areas. The second, the robot grips the workpiece and move to the heating furnace. Task 3, the robot get the workpiece hit workpiece and move from the furnace to the forking press machine. And the last task, the robot interoperating with the forking press machine to locate the workpiece exactly in the dies to complete the product. And about the designing the mechanical systems, we design the robot and the workpiece loading table and feature to the task 4, task 1 and task 4. And the picture on the right of this slide, you can see the robot when after we fabricate it with the fogging machines. And about the design the robot control systems, we not only design the robot arm composite control systems, we also design the control system for whole the system, including the robot, the furnace, and the press machines. And the main difficulty for the control system design is we need to process several input and output signal simultaneously. The control system is designed with the numerical schematic PLC S7. You can see some picture on the slide about the control system to whole system, include the robot, furnace, and press machine. About the validations and testing, we are using the D8 method to modeling the robot with six degree of freedom, and we calculate the applied torque and force for the at the joint of the robot, and we calculate and analyze it, the force and the torque, ensure the accuracy of positions. And the second, we test the functional of the systems and cycle time analysis. We compare in table 3. You can see the comparisons between the manual and automatic. Some targets about the average processing time, about the loading time with the raw materials, and transferring time, and I'm sorry.
Can continue.
Yeah. I lost my network. I'm sorry. You can see on the slide.
Yeah.
Yeah, thank you. The table 1 and table 2 about the list of all the functional tests of the robot arm, and tests from about the task. With for start, I concern about this is the picture of the complete products in the factory, and about the conclusions, we have designed and fabricate a robot with effective technical solutions, and testing the result about the mechanical systems and the tasks and the control systems, and by applying this robot design solution for workpiece transferring, we reduced by more 27% approximately. This the table 3 about the average loading and unloading time. We review about the half between the manual and automatic. For the attention.
Thank you for your presentation. So, any question from the member at the session 1? So for this robot, I have a few questions for this robot. How many robots produce manufacture from your organization? This one.
We we have some robot about this specific this robot. We can fabricate manufacture this robot with can pick up 60 kilogram, and we also design and fabricate some smaller robot and mobile robot, arm robot and mobile robot, and continuum robot. I can present after that the next in the next slide. So about the type of robot. Yeah. Yeah, we manufacture industry robot apply in industries, in medical, and in some small applications for service on our university.
Do you know how much dice cost? What is price for this one?
The price
estimate about 10,000, 20,000. Because the cost, the price for the industry robot now is very important for this kind of design.
Yeah, I see. For example, this robot we manufacture about the cost, the real cost, about the material and human resource and something like that. Yeah, the total cost about, let me remember, about at least maximum 350 million Việt Nam đồng.
So it means about 12,000.
Yeah, 12,000. Yes, thank you. About USA, USD. Some small robot we can fabricate with low cost and very effective.
Okay, thank you, Dr. Bin, for your presentation. I think Dr. Tang is coming back now, so Dr. Tang can present and start your presentation. Yeah, Dr. Tang. The next presentation will be the presentation from Dr. Tang about development of stimulators model for smart manufacturing. Not Dr. Tang, Dr. Hồng Quang. Yeah, Dr. Hồng Quang. Reinforcement, learning based, adaptive, optimal strategy for robotic control system. Okay. Dr. Hồng Quang, are you available? Because I saw the message.
Yes.
Okay, you can start your presentation.
And I want to I want to share this slide.
Okay, I think because can you upload your slide?
Upload.
Yeah,
Okay.
upload and then open. Yeah, you go to file.
Yes.
Yeah, you go to file and upload your presentation, and then you can open.
Yes, I open this slide. Can you see me? Can you see it?
Not yes.
Not.
I think if you can open, so if you see the icon close to microphone, you can see the icons here. Yeah, they have this here button, so you can see it.
But I couldn't click the share button.
Okay, I think I can I see the file you upload? Let me see here.
I upload this work. I upload this slide in the
Okay. I can see your slide now. I can open your slides. Open slides.
Have you seen the slide?
Yeah, I can see. I think I can see the slide for you.
Yes. You can see.
So you can say next.
Yes. And I am presenting. I am presenting my work. Okay. Good morning, everyone. We would like to talk about the problem of reinforcement learning-based adaptive optimal control in robotic control system. Okay, as we know, the control as a robotic system has been described as the dynamic equation. Okay, and the obstacle of the control adjective is to describe in disturbance and uncertainties and constraint force. In order to find the control objective, we can use the sliding surface. We can use the sliding surface with the sliding.
Stop this bit because I think there might be we cannot see the slide. Anyone can see? Okay, wait a minute.
I cannot see the slide.
My slide is in the box.
Yeah. Okay. Now, but I think let me share the slide for all of you. Yeah. Let me see. So can I open this one first? Wait a minute.
Okay.
Fine. I have to download your slide first, and then I can share. So if you say in next, I will. Okay. Wait a minute. Okay.
But I cannot say this slide because the sharing button is not active. Okay.
I can do it for you because
Okay. Have you seen this slide?
Okay. Now I can share the slide to all of you. Yeah. Now I can see now. Okay.
Good.
Yeah.
Now you can see. Okay. Good now.
Now.
Okay. So the full screen so everyone can see. Yeah.
Full screen. Okay.
Yeah.
Full screen.
You go to view. Yeah. Full screen.
Full screen. Can you see? Can you see slide? Okay,
I can see your screen now. I can see your slide.
Yeah.
So you can start your presentation from the beginning. Yeah. Okay.
As we know, the control objective of a robotic system is to find the torque in each joint variable to obtain the trajectory checking of the end effector with the many obstacles, including the disturbance and uncertainties and constraint force. In order to find the control methods, we can use the intermediate variable, including the sliding variable or sliding manifold sliding surface, and the sliding variable plays the role of order reduction of the model of robotic model of a robot. Okay, and the next step, we can use the combination between the framework of optimal control and nonlinear control, and the optimal control can be illustrated in the slide. We can see the Riccati equation, and it is equal to obtain the solution of Riccati equation, and this work propose the dynamic programming technique to solve the Riccati equation. and the Riccati equation has been found by Kalaman in 1968. Okay, and the nonlinear control can be described in the sliding in many sliding variable, and we absolutely transfer the system, the nonlinear system, into the equivalent system to apply the adaptive dynamic programming, and the adaptive dynamic programming plays the role of the convergence of the conversion of the to the sliding surface. Okay, and next step we extend this work by using the chaining rule, of neural network, and the chaining rule of neural network is based on the finding the minimization of cost function, and we can use the technique of the least square. Okay, and the next step we can note that the HZB equation can be implemented by using the two solution. With the first solution is the iterative integral reinforcement learning, and the second is based on the Hamilton equation. Okay, and the work has been simulated in the figure describing the checking of the checking of a robotic system based on the framework. The control scheme is combined between the nonlinear control and optimal control. Okay, and the convergence of the optimal control can be described, can be illustrated, can be validated in this figure. Okay, and the convergence of matrix and the checking of the joint variable. Okay, thank you. That's enough. Okay. But I could not see. I could not hear. I can.
Okay, we can see it now. Thank you for your presentation. So it's now the question time. Anyone have the question, Dr. Bin? Do you have any questions for Dr. Hong Kwang, because it's in the area of research?
Actually, I can see the first slide and the some slide I cannot see.
Yeah.
So I only hear you said. Yeah.
Okay. The first slide and the second slide.
Second and third, and after that I don't see.
I think there might be the slow connection, the internet connection, so we cannot see.
Yeah.
Anyway, if you have any questions,
I understand what you say and implement it.
The control method is decided based on the framework of nonlinear control and optimal control. With the by using the sliding variable, we can reduce the order. We can reduce the order of the equation. And next step, we if the system comes converges to the sliding surface, we come to the sliding surface, and the optimal control has been implemented for this system in the sliding surface.
Okay, thank you. So if anyone have a question, can you post your question in meeting chat? Yeah, so we can because it can open for today and also tomorrow. The presenter can reply to you later. Okay, thank you, Dr. Kwang.
Thank you so much.
The next presentation is for Dr. Ching means it's linked to presentation title is the role of the big data analytics and artificial intelligence in smart manufacturing, the overview. So it's part of the project on Fin Group and Newton Fund.
Yeah.
Okay, you can start now. You can share. Can you share your screen because we cannot see. Yeah.
Yeah. It's my screen, as you can see.
Okay, now you can see now. You can start your
Yeah.
presentation. Okay, thank you.
Yeah, I start to present the role of big data analysis and AI in smart manufacturing. This is an overview paper, and I can show some contents of this paper on the slide. I focused on two major parts. The first is the role, the overview of research on the big data analysis and AI in manufacturing, and discussions and conclusions. The first, we can see the smart manufacturing is the core of the Industry 4 regulations, and Internet of Things, big data, AI, cloud computing, digital twins, cyber physical systems, and some parts have motivated the development of smart manufacturing. And in this paper, we show some review of recent publications related to smart manufacturing. We focused on the big data analytics and AI, consisting of CNC machine and robot systems. We define the small thing, a scope of our research project. Manufacturing is focused on the fabrication by machine tool and robots. It means the system combining robot and CNC machines. The key of smart manufacturing can be identified more especially as the industry's connectivity device, robot, and CNC machine with big data processing platform. About the data in the big data of smart manufacturing software, we can divide it into three main. The first group is the data of machine data. It can include the machine layer, such as feed rate, some parameter about the spindle speed of CNC machine, the current and voltage of electric motors, vibration signal or product imager, and some parameter, other parameter. The second group of data about the production and service include the design data in design product and make the provide product to market. And the last group of big data for the production management includes the production plans, resource plan, inventory plan, quality control, and subcontracts. We can define some informations. The first part, we can see the overview of smart manufacturing. We surveys some document from 1 to 14 documents, and the most of previous investigations concerning with smart manufacturing about the overview big data analytics focus on the comprehensive review of state of the art and detail the discussion the general framework design, general approach and key technologies that are necessary to rely actual smart factory. About the general frameworks, layout, architectural and functionalities and other theoretical about the smart manufacturing focused on big data analytics, we can see on the 15 to 36 and some document. And about the experimental investigations and numerical simulations for demonstrations of conceptual design related to smart manufacturing and AI and big data analytics, we can see some on the document, and their documents investigate the demonstrate the conceptual design, some characteristics of big data driven smart production platform that concentrates on the individual machine, for example the CNC machine or single shop robot. It's so to specific, and we realize that when we combine the CNC machine and robot, it's so much the challenges. With three content: the first overview, the smart manufacturing; the second is general framework; and the last is the experiment investigations. We have some comment. Most of research was related to advanced manufacturing systems, smart manufacturing, or and AI and big data analysis, focus on the general framework, general approach and technology. The second, there have been publications present the experimental result, but mostly aim to demonstrate conceptual, examine a concept model or some characteristics of big data and AI driven smart. And the third, theoretical development of and experimental investigation accompanied with numerical and real-time demonstrations of smart shop floor consider real CNC machine and robot are challenging because some documents, some researchers focus on the single CNC machine or single robot. And the training for construct AI algorithm is based on the limited experimental data collected with some experimental scanner nodes based on the digital twin layer and an online big data processing frameworks. And about the in general, in conclusions, there's a great potential when using AI and big data analytics with the purpose of improving the smartness of single manufacturing systems as well as smart manufacturing shop floor. A real application in industries is still at the beginning stage. This is the important comment. And in fact, there is an amazing need for today manufacturing, that is how to rely and develop the smart manufacturing systems such as smart industrial robots and smart computerized numerical control systems. And in the future of the smart manufacturing, robot and CNC machine products could be designed and developed in with AI control, with it rely on the big data platform, and I think it's so important. And thank you for your attention about the overview paper. Yeah, thank you.
Okay, thank you. I think only is Dr. Van Kang active. Do you have any question for this presentation? Okay, so if there are no questions, so we can start for the next presentation also, Dr. Bin, yeah? The next presentation.
Thank you, thank you.
Yeah, we can start the next presentation about forward and inverse kinematic analysis with present reassessment continuous support.
Yeah.
You can see as a screen. Yeah, you can start now. Thank you. Yeah, I can see it now. Okay.
This is the last report on the title of the last report is forward and inward kinematic analysis of special three-segment continuum robot. It's the special type of robot, and I can present some part the modeling and analysis and some result simulations and some comment. As we know, soft robot it rely on the mimicking locomotion mechanism of soft body existing in nature to achieve smooth and complex motions. We can use this type of robot for many applications in medical, in army, in some area of service. You can see the continuum robot are a type of soft robot. We can design the continuum robots based on mimicking locomotion mechanism of soft body existing in nature, such as octopus, snake, elephant trunks. And our report present a spatial three-segment continuum robot with elastic backbone. You can see the last picture. We designed a robot such as this picture. On the right of the on the slide, and forward and inward kinematic problem we are solved by DA technique and closed inward kinematic algorithms. This is the diagram of modeling three segment of continuum robot. We can define this modeling with some parameters. The first is the angle, the directions, angles, and the curvatures of each arc. The first arc, the second arc, the last arc, and we have the L1, L2, L3 is the length of each arc. We can see the homogeneous matrix, transformation matrix, and we can calculate the positions of an effector in fixed frames. You can see the last formulations include the coordinate systems and the orientations. We build the forward kinematic and inward kinematic equations based on the You can see the diagram for the forward kinematic, and this is the algorithm to solve the inverse kinematic problem. We use the closed loop inverse kinematic algorithms based on the error between the positions of design and actual. Result of the forward kinematic problem, we have some input data about the length of the three segments, and we have the rules of parameter, the curvature, the bending angles, and orientation angles. This is the input data. And the output data of forward kinematic problem, we have the positions of the endpoint of robot, the velocities, and the workspace of robot based on the input data. About the results of the inverse kinematic problem, we have the input data, the design tune path or design the trajectories of endpoint of robot. This is two diagram about the design endpoint and design velocities. And the output of inverse kinematic problem, we have the curvature, bending, and orientation angles, and we have the path error of endpoint in workspace. This is very important when we use the closed loop algorithms for solve the inverse kinematic problem. About the initial experimental model, we design and fabric a continuum robot with one segment. And in this paper, I modeling for 3 segments, and I fabricate a robot with 1 sections with some material about the step motor, the STM main board, and step motors, and some material. About the problem I used to implement the experimental input data, I input some power of for step motors, and we can calculate the length of data with each coupler-wise, and we determine the position A and B on the workspace, and this is the output of the forward kinematic problems. And in the conclusions, we realize that we determine this paper consider analyzing kinematic modeling. The second, we build the forward and inverse kinematic problem, inverse kinematic equations of the spatial 3 segments, and simulation result between for 2 problems by using the closed loop algorithms for inverse kinematics, and we have a real model to describe the motions, testing the results of forward kinematic problems. And that's all of our report. Thank you for your attention.
Okay, thank you, Dr. Dean, for your presentation. So if anyone have a question for Dr. Dean about this project, very interesting, robust. What is the next research plan for this kind of project?
Yeah, in the future, I would like to focus on the design and implement the control systems with some intelligent controller, for example, neural network or adaptive I can design the control systems, and we can apply for some area applications about the medical, for surgery, on the arm of robot to interactive with a human. I think is very possible area for application of this type of robot.
Okay, thank you very much for your presentation. So, if anyone have any questions, you can post your question in meeting chat. Yeah. So I think we have the last presentation from Dr. Sama, who can start the presentation now. The presentation topic is smart wheelchair, remotely controlled by hand gesture. Okay, I think Dr. Sama, can you?
Good morning, sir.
Yeah.
From where I can, I have uploaded my presentation. However,
yeah, you can open the presentation from Microsoft Teams, and then you can click on the icon share button, so everyone can share. Yeah. So can you open the file share screen?
I'll go to the files. Now I can't see that actually. Microsoft Teams. Oh yes, I got it. Is it visible, sir? Hello? Sir, can you see this? Is it visible to you?
I cannot see the screen, your screen, so you have to click on share icon, so if everyone can share. Okay. I
Sir,
can
this
hear
okay, yeah. This icon is disabled for me actually.
Can you see the share icon now?
Yes, now I can see share icon.
Yeah, you click the share icon so everyone can see now. Yeah.
Now the press PPT has gone.
When you click to the share icon, you can see like your presentation or whole screen share.
No file available. Screen. File.
In the meeting chat, the image, so the icon.
Now I did that. Now can you see that?
Can you wait? Yeah. Not yes. Yes.
Is it visible to you, sir? Good to go?
I think can you click to the icons here?
Yes, I clicked on share.
Can you go to meeting chats and the technical support for you? Yeah. It's the icon. Yeah.
Chat, yes.
You can click on share icon. Yeah.
It's not chat actually.
I think I can support for you. I think I can share the screen. So so when you do presentation, you can let me know which slide you would like to do. Yeah. Okay, I can see the screen. Yeah.
Um, yes, I can see it now in your screen.
Okay.
It's visible. But can I move it?
Yeah, you can present. You can say everything, so I can control the screen for you. Yeah.
Okay. Perfect. That sounds better. I'm so sorry what is going on. Anyways, for all of us, this is the first experience. Thank you so much for your support. Well, moving forward, I'm Dr. Hemlata and I'm presenting my recent work that we have developed a prototype. Although it is not as an industry 4.0 concept, however, it actually helps out as a wheelchair which is controlled smartly with the help of hand gesture. Just by using the hand gesture, we can actually control. So can we move to the next slide, please? So, yeah, thank you. So as an introduction slide, I would like to tell you like this wheelchair is important for us, reason being there is 10% of total population across the world which is actually physically disabled. So to solve this kind of a problem, we need to have a solution which is not only that the solution is available, but it should also be cost effective. So this prototype is actually cost effective. So the 10% of the across the globe population, now you can consider it as a 650 million people across the globe. Apart from this, it can be used by other people by using other parameters like old age people, those people who are actually physically ill, and so on. So the challenges of the physically disabled persons are many. So considering those many challenges, it gave us a cue to develop this kind of a wheelchair, a smart wheelchair device. Here we have developed an exceptional type of wheelchair which make them to feel self-dependent, because they'll be able to control this wheelchair by their own. This wheelchair works just with the movement of the hand gesture, as and when they'll move the direction of the hand upside, the wheelchair will move on towards that particular direction. So in total, the wheelchair handles 5 particular directions. It is proposed in this paper that it is, of course, a cost-effective affair that I have already discussed with you. We'll move to the next slide for more clarity. It gives you the gist of the abstract. So the next slide is abstract. Next slide, please.
Yeah, wait a minute. It's a little bit slow for me, I think.
Oh, thank you. So, in short, although I have told you the idea behind this development of this kind of a prototype, but the abstract actually shows you the gist of this. This is a hand gesture controlled wheelchair, which I'm calling it as a special kind of a movable device which can control the motion of wheelchair at right direction through the hand movements of any person. So this proposed system can be categorized into 2 different specific units or parts. The first unit we are calling it as a gesture unit. So this gesture unit actually controls the gesture or the movement of the hand, which has been passed through the sensor to the wheelchair, and this is received by the DC motor of the wheelchair, and the motor receives the commands, and accordingly movement passed on. So the proposed work, you can see eventually there are few components aligned. The one is accelerometer. So what it does, we are using it as this accelerometer as an sensor for us. So it passed on as an analog signals. In order to convert this analog, we have used a comparator which actually converts it into the digital signals, and then it encoded by passing through the RF transmitter. However, it is not necessary that you need to encode it and then decode it. But why we did it? Because so that devices should not have any sort of miscommunication. Once it reached to this, now the data is decoded and passed on to the Arduino Lily pad, which is again gives the receiving end will receive the command with the help of the DC motor. DC motor receives the command, and finally the movement of the wheelchair will be done. So this is the holistic proposed framework. Now we'll move to the next slide for better clarity. So the use case, the overall framework, basically the use case says the user is our that physically challenged person. So here we have to set up a device. Once the device is set up, we should always have a start button. So the start button capability, as in when the start button is on, then only device will kept on moving. All right. So the next is the performance gesture. So when we move to the performance gesture, and the last one is the stop command. But the sequence diagram will provide you the better clarity in this aspect. So this says the user and we have a system. So there is a communication required between the user and the system. So what happens? User passed on the request to the device once the system is up. So when it is on, with the help of the LED, it will come to know that yes, it is functional now. And the gesture performed by the user in whatever direction it is, which is again read by the system and passed on as per the command. The reflex is passed on to the user, and finally the function will move on. Let's go to the next slide. So the working principle, as I've already told you, the specific type of movement of hands, that is the forward command, backward command, stop, right and left. So there is the transmitting device actually tied up with the hand of this person. So they may use it by wearing a gloves as well. But what kind of a command it shows? If it is in the forward direction, the hand should be moved in forward direction. Backward direction, it goes back. If it wants to say like stop, then it has to be in the straight position. However, if you move it to the right direction, it goes into right, and for left, it goes into left. So the important aspect is accelerometer, because it is a 3-axis accelerator. So, and we, as I told you, we have used it as an sensor for us. So the phase, it is and of course, this also I have explained to you the magnitude and the direction of acceleration. That is the only reason we consider it as a sensor for our model. Next slide, please. Yes, so the results in the conclusion, the accelerometer mounted on the transmitter gives the value that has been generated from the movement of hand, and these values are received by the microcontroller, and it gets processed by that way. Now, according to the control algorithm, this microcontroller processes the command. So let's go to the next slide. So in past as well, so patient can perform the 5 commanding actions, whether it is moving forward direction, backward, left, right, and all. So the patient, when tilts its hands towards forward, as I've told you, the wheelchair moves according to the direction which has been moved or sensed by the accelerometer. In addition, by simply sliding the button on the transmitter, the device becomes active and wheelchair can be operated. So as soon as the button is slid back, the device becomes inactive as you need it to start. So similarly, you have to make it inactive as well. So making it again, you have to slide off the button. Next slide. Can we go for the next slide, please?
Yes, it has the future work. Yeah, it is a future work. Yeah.
So before going to the future work, one more thing I would like to add on over here, because this is not only the different type of work, because I have gone through the literature in the past. There were some how wheelchair has been controlled by the sensors. So there were studies which had actually told us, like by neck movement as well, you could control the devices. However, it was not left, right, forward and backward. Another aspect they have used, another researcher have used the movement of the eyeball. For that, they actually captured the camera. So camera used to capture the images of the eyeballs. But actually, it was very, very costly affair. Then the little cheaper kind of a voice recognition. However, the voice recognition was cheaper, but as when it goes in a noisy atmosphere outside of this, so in that case it became very, very difficult for them because it disrupts. But our case is actually cheap and a different kind of a profile, and many people can use it because it's not necessary that everyone can afford it. That was the noble idea behind this kind of a work. Well, before ending it, I would like to discuss the future work as well. So it is controlling of speed. So next thing we can think of, as and when required, we'll increase the speed of the wheelchair, and accordingly we can. Right now, it is moving on the limited or the constant speed. Obstacle detection can also be introduced. However, for health monitoring devices, we can also install these kind of, for BP monitoring, for these pulse rate. Also, we can have a band attached to it, and the signal can be passed on. GPS embedded where the device is, where the wheelchair is. We can enable this embed this kind of GPS facility as well, which will actually make it simple and easier. That's all from my end, and thank you so much for your support. Is there any question from your end?
Yeah, thank you very much for your presentation. So does anyone have the question for the presentation? Yeah. Any question? I think for you you design the control of speed is very important. I think, yeah, for the safety.
Yeah, correct.
Yeah. So how can you control the speed? Because it's very difficult to
right now it is
capture. Yeah.
Okay, right now it is based on the movement, because as and when the the hand says stop, then automatically it stops. That is the reason there is a difference between the start and end. Start, I should say, end and stop. So just by using the hand, the control says here the stops, don't move forward. So accordingly, it can stops. However, but this is possible only if a person is attentively sitting on the wheelchair. But yes, we can introduce it. The variation is also required. So that was the idea, because it is easily available, and easily available in the sense quickly you can add on, because the wheelchair which is readily available in the market, you can install it into that particular chair, and accordingly quickly the chair is ready for the movement.
Yeah, I think you can apply the mass customization principle and easy for the design.
Yes.
Yeah. Thank you. I think maybe this is the last presentation for our session. Thank you very much for your presentation. So if anyone have any question linked to our presentation, so I think here we have totally 11 presentation. So if you have any kind of questions linked to all this question, you can put your question in the chatting menu of Microsoft Teamwork. Yeah, so we have this afternoon and tomorrow for the presenter can reply to your question. Okay, so any question from all the team member? Yeah, no question. We can finish our session here today. Successful organizing the session. I think our session should be the first one to finish. So on the presentation.
Thank you so much, sir. Thank you, everyone.
Okay, thank you. Yeah. Okay, I think we can finish our session here. Thank you. We can see one of you in the afternoon for the keynote presentation in the afternoon. Okay.
Yeah, thank you.
Yeah.
Em chào thầy ạ.
Okay. Bye. Bye everyone. See you for the presentation. Yeah.
Yeah.
Okay, bye bye, Dr. Sama. Bye bye.
Bye bye. Thank you. Bye.
Okay, thank you. Yeah.